Hello, this is the section 3.3 lesson. In this section we're going to talk about the standard algorithms for doing addition and subtraction. We're going to start off by reviewing how these algorithms work, and then we're going to talk about why they work and what we're really doing in each step. So let's start off with a definition of the word algorithm. An algorithm is a method for carrying out a calculation, or as the book calls it, simply a recipe. It's a set of steps that if you follow these steps properly, you will get the correct answer. So let's review the standard addition algorithm with a couple of examples. So 149 plus 85. And so let's write down these numbers, 149 and then 85. And we write them down so that the ones digits line up and the tens digits and then the hundreds digits and so on and so forth. And so now we start off by adding the ones digit together. 9 plus 5 is 14, so we write down the 4 here, and then we carry a 1. And so now we add 1 plus 4, which is 5, plus 8, which is 13, so we're going to write down the 3. And again, we're going to carry a 1, so now we go 1 plus 1, well that's 2, and so there's our answer, 234. So there's one example of how the standard algorithm works. Now let's do another simple example here dealing with some decimals. So 34.5 plus 7.89. And so we again write down these numbers, 34.5. And then we're going to write down the second number, and we need to make sure that the decimal points line up, 7.89. And then we add. Okay. Now notice that this first number only goes out to the tens place, whereas this goes out to the hundredths. We can put a 0 here in the hundredths place if we want. It's not really necessary. But then we go 0 plus 9, which is of course 9. Now there's nothing to carry, so 5 plus 8 is 13. 3, carry the 1. Now we need to bring down the decimal point as well. So then 1 plus 4 is 5, plus 7 is 12. So we write down the 2 and carry the 1. And so now we go 1 plus 3, and that's 4. And so there's our answer, 42.39. So the algorithm works pretty much the same for whole numbers as it is for decimals. We just have to make sure that all of our places line up. The ones place, the tens place, the hundreds place, the tens place. Everything's got to line up. So now two questions we might ask, and we're going to try to answer these. Number one, why does this algorithm work? We all know how it works, but why does this work? And then second, what does it really mean to carry a 1? What are we doing when we carry a 1? What are we really doing there? So we're going to try to answer both those questions. And to answer these, especially the second question, we're going to go back to the meaning of numbers that we talked about in Chapter 1. So let's start answering this question with a very simple example, 15 plus 6. And so let's do the common algorithm, 15 plus 6. And so 5 plus 6 is 11, so we're going to write down a 1, carry the 1. 1 plus 1 is 2, so there's our answer, 21. Now, to illustrate what we're doing here, and specifically what does it mean to carry a 1, we're going to draw a picture of what these numbers mean. So the number 15 means that we have one bundle of 10 and then 5 individual objects. So let's draw a picture like this. Here's going to be a bundle of 10 and then 5 individual objects, 3, 4, 5. So here in my picture, a straight line like this represents the number 10, and then a dot represents the number 1. So there's the number 15. Now the number 6 is just 6 individual dots, 1, 2, 3, 4, 5, 6. And so now we want to add these together. And so we're going to combine all of these objects over here together. Well, if I notice right here, I have 6 individual dots. Or excuse me, I have 11 individual dots. 5 plus 6, 11 individual dots. In the base 10 system, we don't like to have more than 10 of any item or any bundle of items. So let's do this. Let's bundle 10 of these items together. So let's draw a box here around 10 of these, and then let's kind of move that bundle of 10 over here. So now we're going to bundle those together and move that over to the tens place. Okay? And so now what do we have? Well, we've got just two individual bundles of 10 here, and then we've got one individual object. We don't have more than 10 of anything, so that's good. And so what's left? Well, we have two bundles of 10 and then one individual object, and so there's our answer, 21. Okay. So we see here that when we carried this 1, what that really represented was this idea that we're taking 10 individual objects, bundling those together, and then moving them over to the tens place like that. So let's illustrate this with another example. 149 plus 85, which is an example we did earlier, but let's just redo it to refresh our memory. 149 plus 85, and so 9 plus 5 is 4. We carry the 1. 1 plus 4 is 5, plus 8 is 13. We carry the 1 again, and we get 2. And so let's draw a picture here to illustrate what we did. So number 149 means we have a bundle of 100, 4 bundles of 10, and then 9 individual objects. And so let's draw a box like this to represent a bundle of 100, and then 1, 2, 3, 4 lines there to represent 4 bundles of 10, and then 9 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Okay. Now 85 means that we have 8 bundles of 10. And so 1, 2, 3, 4, 5, 6, 7, 8, and then 5 dots. 1, 2, 3, 4, 5. And so now we need to combine all these together. Well, let's start off by combining the individual objects, the dots there. And so we see that we've got 9 here and 5 there, so that's 14. And so let's bundle 10 of those together, and we're going to have 4 left. So let's see if we can do this. Let's kind of circle these 10 right there. And so now we're going to cross those off, and we're going to move this over here to have another bundle of 10. So grouping these together, moving that bundle of 10 over there is what we did here when we carried this 1. And so now, if we look here at our bundles of 10, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 bundles of 10. I don't like having 13 bundles of 10. And so let's group 10 of those together. And so let me draw a circle around 10 of those. So there's 10 bundles of 10. And so let's move this over here to form another bundle of 100. So let's somehow cross those off to indicate that we've moved those over. And so now what's left? Well, we have 2 bundles of 10, 2 bundles of 100, 3 bundles of 10, and then 4 individual items. And so what's left? Well, 234. So there's our answer. So again, I hope you see how this idea of bundling or grouping 10 items or 10 bundles of items, carrying that over, or moving that over to the next place, that's what we're really doing when we carry a 1. Okay. Now let's do an example dealing with decimals, and we're going to draw a similar type picture to illustrate what it is we're doing. So let's do the common algorithm, 1.2 plus 2.9. And so 2 plus 9 is 1. We're going to carry the 1, bring down the decimal point. 1 plus 1 is 2, plus 2 is 4. So 4.1. So let's draw a picture here of these two numbers to illustrate what it is we just did. So the number 1.2, when we drew pictures of decimals back in chapter 1, we drew similar type pictures as what we did with whole numbers, but we're going to define things a little bit differently. So in our picture here, let's let a dot equal the number 0.1. 0.1, that's the number 1. And then we're going to let a bundle of 10 be a straight line. That's a bundle of 10, and that's going to represent the number 1. And so in our picture here, 1.2 means we have one bundle of 10 and then 2 individual dots or individual items. 2.9 means we have 2 bundles of 10 and then 9 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so now we need to add these together. Well, we're going to start off on the right here looking at our individual items. We see that we have a total of 11 individual items, and so let's bundle 10 of those together and then move those over there to form a new bundle of 10. We'll just cross that off. And so now we see that we have 4 bundles of 10. That's no more than 10, so that's good. And we've got one individual object. And so what's left? Well, we have 4 bundles of 10 and then one individual object. That one individual object represented the number 0.1, and so there's our answer, 4.1. So this is a similar type picture we did with whole numbers. The idea behind the algorithm for decimals is really no different than the algorithm for whole numbers. So what I hope we see from these examples is to illustrate what it is we do when we carry 1. Carry 1 really means regrouping. Specifically, that means that we're going to take 10 items or 10 bundles of items and bundle them together or group them together to form a bigger bundle. So that's what we're really doing when we carry a 1. It means that we are regrouping. Now let's illustrate some examples of dealing with subtraction. And so 142 minus 83. So let's write this down in the same way as what we did with the addition algorithm. Make sure that places line up, the ones place, the tens place, so on and so forth. And so now we need to subtract. So we need to take 2, take away 3. Well, 3 is more than 2, so we need to borrow here. So let's cross that off, write a 3, and then we're going to make this a 12. So 12 minus 3 is what, 9? Now we want to take 3 minus 8, but we don't have enough there to take away. So again, we're going to borrow 1. That becomes a 0. That's going to become a 13. So now 13 minus 8 is 5. And so there's our answer, 59. So that's how the algorithm for subtraction works. Let's do another simple example to illustrate how the subtraction algorithm works dealing with decimals. And so we're going to take 100.2 and we're going to subtract 5.3. So write these down as always, make sure that the decimal points line up so that all of our other place values line up. We want to take 2 minus 3, but we don't have enough to subtract, so we need to borrow. So we need to borrow from here, but there's nothing to borrow from, so we need to we're going to go over here. There's still nothing to borrow from, so we're going to go over here. And so let's borrow 1 from here. So let's write that as a 0. And then this is going to become a 10. Now we need to borrow. So this is going to become a 9. And this is going to become a 10. And so now we have something to borrow from here. So this is going to become a, this is going to become a 9. And this is going to become a 12. And so now we can subtract. 12 minus 3 is 9. And bring down the decimal point. 9 minus 5 is 4. And then here we have 9 minus 0 is going to be 9. And then over here it's 0 minus 0 because there's nothing in the hundreds place. And so there's our answer, 94.9. So let's ask the same questions as we did with the addition algorithm. Why does this algorithm work? And then what does it mean to borrow? What did we really do when we borrowed a 1 from one's place, or from one place and then brought it over to the next place to the right? What does that really mean? Well, let's illustrate this with a very simple example, 15 minus 6. So 15 minus 6. We subtract and you take 5 minus 6, but there's not enough, so we need to borrow. That's going to become 0. This is going to become 15. 15 minus 6 is 9. So there's our answer. Okay, so there we had to borrow in order to do that subtraction. Well, let's draw pictures here to illustrate what we did in those steps. So the number 15 means that we have one bundle of 10 and then 5 individual objects. 3, 4, 5. So there's our 5 individual objects. Now we're not going to draw the number 6 because we're not adding 6, we're going to take away 6. So 6 means that I need to take away 6 individual items. Well, if I look at the individual items here, I see that I don't have 6 to take away, I only have 5. Well, that's okay, because what we can do is take this bundle of 10 here and unbundle it or regroup it. And so let's do this. Let's draw an arrow here to the right, and let's unbundle that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we'll cross that off to indicate that we are ungrouping that bundle of 10 or unbundling it or regrouping it, however you want to think about it. Okay? And so this idea right here, when we took this bundle of 10 and unbundled it, that's what we really did when we borrowed a 1 from over there. Okay? And so now we have more than 6 objects to take from, and so let's take away 6 of these objects. So 1, 2, 3, 4, 5, 6. Doesn't really matter which 6 we take away because they're all the same. And so what's left? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 individual items left, and so what's left is 9. So there we go. That's what we did in that algorithm. And this is what it means when we borrowed a 1. We took that bigger bundle of 10 and we unbundled it or ungrouped it or regrouped it, however you want to think about it, so that we had more than 6 individual objects to take from. And then we took away those 6 objects, and what was left was 9. So let's do another example that's going to illustrate this idea of borrowing again. So we have 102 minus 25. So let's do the standard algorithm here. 2 minus 5, we don't have enough there to take from, so we need to borrow, but there's nothing to borrow from, so we're going to borrow from over here. So this is going to become 0, this is going to become 10, and then we'll borrow from here, that's 9, and then we have 12. So now we have 12 minus 5 is 7, 9 minus 2 is 7, and so there's our answer, 77. And so let's illustrate what we did here with pictures. So we're going to start off with the number 102. 102 means we have one bundle of 100 and then 2 individual objects. And so let's draw a bundle of 100 here, and then we're going to have 2 individual objects. I'm going to leave a big space there, and you'll see why we do that in a bit. So we need to take away 25. So this means that we need to take away 2 bundles of 10 and 5 individual objects. Well, I don't have 5 individual objects to take away, nor do I have 2 bundles of 10. So we need to borrow, or we need, to solve this, we need to ungroup. So to do this, let's take this bundle of 100 right here and ungroup it so that we have some bundles of 10. And so let's draw this like this, and we'll have 10 bundles of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there we go. We just borrowed from that hundreds place, or in pictures we just unbundled this group of 100 into 10 bundles of 10. Okay. So now I've got plenty of bundles of 10 here, but I still don't have enough individual objects, so I need to take away 5 of those. Well, let's solve that problem by taking one of these bundles of 10 here and unbundling it. So let's maybe take this first bundle of 10 here, draw an arrow, and we'll draw 10 individual dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's our 10 individual objects, and we'll cross that one object, that one bundle of 10 out to indicate that we unbundled it. So that's what we did here when we borrowed a 1 from the tens place. We took one of those bundles of 10 and broke it up into 10 individual objects. Okay? And so now we can start taking things away. And so we need to take away 5 individual objects. So let's take away 1, 2, 3, 4, 5 of those. And it doesn't really matter which 5 we take away as long as we take away 5. So there we just subtracted the 5. Now we need to subtract this 2, which is in the tens place. So we need to take away 2 bundles of 10. So that's 1, 2. And so then what's left? Well, we've got 1, 2, 3, 4, 5, 6, 7 bundles of 10. And then we've got 1, 2, 3, 4, 5, 6, 7 individual objects. And so 7 bundles of 10 and 7 individual objects is 77. So there's our answer. That picture illustrates what we did in each step of our standard algorithm over here. So to summarize what we saw in these examples, when we borrow, what that really means is that we're again regrouping or ungrouping. We had a big group of 10 or more objects, and so we broke that up. So we ungrouped it, or we unbundled it, or in generic terms we regrouped it. So that's what we do when we borrow. Notice it's very similar to what we do when we carry a 1. It's just kind of the opposite. Instead of taking 10 objects and putting them together to form one bigger bundle, we take one bigger bundle and break it up to form more smaller bundles. So that's it for the section 3.3 lesson. Your assignment before next class is to read section 3.3 from the textbook. And the textbook is going to talk about some different ways of explaining the algorithm, and it's going to talk about what they call an expanded form, or things written symbolically, and I think those are more complicated than they're worth, so just ignore any mention of those forms.